Right, now we can look at more examples of the negations of quantifier statements. And in actual examples here, we include not only the exists universal, but also the conjunction, disjunction, and conditional statements we have learned before. So the first example, for any integer, for any actually, we can use a real number. And for any positive real number, x, if x squared is greater than or equal to 9, then x is greater than or equal to 3. Okay, so as you can see, for any, that's the universal statement. And instead of having a simple statement about x, we have another conditional statement, if-then statement. So if we remember, when we do the negation of a quantifier statement, we change for any to there exist. So pretty much for any x in any positive real number r, real number x, and so we're doing negation here, following the sort of like a formula or pattern we learned before. And also we need to negate. So this whole conditional statement is describing something about x. So this will be negated. So we gotta negate this whole statement. And because this is not a just simple statement like we had before, and the school bus x is yellow, we just put it is not yellow. In this case, we have if then, so we have to use what we learned before, how to negate a conditional statement. So if you remember, the negation of conditional statement is congruent to we keep the condition P and we change the conditional statement to a conjunction and we negate the conclusion Q. So in this case, in order to negate this conditional statement, I keep x squared greater than 9 and negate the conclusion of this conditional statement. X is less than 3. Greater than or equal to 3 becomes less than 3. So the negation of the statement will be there exists a positive real number x. I should put such that x squared is greater than or equal to 9 and x is less than 3. So that would be the negation. So when we do the negation of a compound statement, we can do, in this case, we do 2 steps. First, we use sort of like the formula for a negation of universal statement. Change for any to there exists. Negate the statement about x. But this statement is conditional statement, so we follow the negation, the formula of the negation of a conditional statement, which is keep the condition, negate the conclusion. So we put them together, that would be the negation of this compound statement. Now look at the second example. For any real number x, if x squared equals 9, then x is equal to 3 or x is equal to negative 3. Now notice that this statement is even more difficult than before because it involves a quantified statement, a conditional statement, and a disjunction or. Okay, so in this case, we have to do 3 negations. So first step, still, we're going to negate for any. So when we do negate for any, then we change it to there exists a real number x such that, Now, next part is conditional statement. The same formula. We keep the condition x squared equals 9. Change then to and. Of course, we get rid of if. The next part is we need to negate the conclusion of this conditional statement. So x equals 3 or x equals -3, that this disjunction together, these two together, is the conclusion of the conditional statement. Because for conditional statement, we gotta negate the conclusion. So this goes back to the negation of a or statement. That's De Morgan's law. We know it's negation of P and negation of Q. So we gotta change or to and. So we write down the negation of the next part. And x equal to 3. X is not equal to 3 because we negate both of them. Negate for the negation of the or statement, we negate both of them. Change or to and x is not equal to 3. So this whole thing together will be the negation of this compound statement. So there exists a real number x such that x squared equals 9 and x is not equal to 3 and x is not equal to -3. Again, here we don't have to determine if the statement is true or false. We just need to write down the negation. As we know, if original statement is true, then negation will be false.